Hello and welcome back to Yeyu Lab. Today we are diving into the context-aware framework, which is a concept that Google just published a really insightful blog post about. And I'm going to show you how to apply these ideas into practice using Google's ADK. So here, most people think big context window solve everything when they use LLM by just through more tokens, right? But the answer is no. This article makes a very clear argument that this approach doesn't scale and show you how to replace it. So today I'm going to walk you through the key concepts from this article, and then we'll build a working demo about the document research process that puts these ideas into practice. By the end of this video, you will understand why context should be treated as a compiled view rather than a stream buffer. So before we get started, you will have your ADK installed and a Gemini API key ready. So let's go through the article. Firstly, Google identified three pressures that breaks the just through more tokens added approach. The first is the cost and latency spirals. It's that more tokens means slower responses and higher bills, right? So second, loss in the middle. This is actually a well-researched phenomenon when you stuff in relevant logs, stale tool outputs, and deprecated state into the window. The model has problems for sure on noises instead of actual instructions. And the third is the physical limits, even million token window overflow eventually. So real workloads with RAG results, conversation history, and tool outputs add up very fast. So the key insight from the blog post first, and I think is really important, is throwing more token at the problem buys time, but it doesn't change the shape of the curve. So to scale, you need to change how context is represented and managed. And then we will move to the next to see how the context being represented and managed. The blog then proposed a mental model shift. Instead of treating context as a mutable stream buffer, treat it as a compiled view over a richer stateful system. Think of it like a compiler. Your raw data, including sessions, memories, artifacts, is the source code. The processing pipeline transforms it. The working context is the compiled output, which is optimized for this specific invocation. So here, once you adopt this mental model, the context engineering stops being a prompt engineering and starts looking like a system engineering. That's a really powerful shift in thinking. The blog outlines three design principles that ADK framework follows. One is the separate storage from presentation, which means the session is your persistent storage, working context is your temporary view. They evolved independently. The second is explicit transformations, which means the context is built through named ordered processors, and then the scope by default, which means every model call sees the minimum context required. Agents reach for more information explicitly via tools. Now let's look at how ADK actually organizes context. So the blog describes a 4-layer architecture: working context, session, memory, and artifacts. So let's see one by one. The first working context is what gets sent to LLM. It's temporarily thrown away after the call. The session is the authoritative record of the interaction. Every message, tool call, and result is captured as a structured event object. And the memory is a long-term knowledge that outlives a single session, user preference, past decisions, domain facts retrieved on demand. And the last one is artifacts, which is really important. Larger binary or text objects, including PDFs, CSVs, images. they are addressed by name, not passed into the prompt. You can check the rest of this article to see the details of the structure. Now let's see the document of ADK, which is the Agent Development Kit from Google. And from its context category, we can look at how this architecture and concepts of the context engineering into actual ADK code. The ADK documents describe different context type for different situations here. So if you remember the scope by default principle from the block, the ADK implements this by giving you a different context objects with different permission levels as well. So first, let's see the tool context, which will be used more frequently. This is what your tool function receives. It gives you access to state for reading and writing session state. You can save artifact and load artifact for handling large files and search memory for retrieving long-term knowledge. This is the most common text you will see. And let's move back. The callback context is similar but used in agent callbacks. Like before model callback or after tool callback, you can modify states or artifacts, but you don't get memory search here. Let's go back to see randomly context, which is for instruction providers functions that dynamically generate agent instructions, and you can read state but not modify it. This enforces the principle that instruction generation shouldn't have side effects. Now let's see the first one, invocation context, which gives you full access to everything, session, memory, artifacts, and even the agent hierarchy. Most of the time you should use the more specific context types from my experience. And when we move down, it gives you common tasks using context. You can see clearly in details there. And the ADK docs here also mentioned state prefixed here using prefixes. This is how you implement the separate storage from presentation principle at the state level. Here it gives you some options like app is for the application level data shared across all users whose configuration settings and features flags shared resources available. And the user, which is for user specific persistent data with a proper session service. This service is across the sessions, and user, including user preference, history, and personalized settings. And the temp, which is for temporary data within a single invocation. When the agent finishes responding, the data is cleared, and this is perfect for passing data between tools in a single turn. So without further ado, let's see the demo code. So we built a demo that demonstrates these context engineering patterns in practice. So here is a document assistant with 5 tools that demonstrate different patterns. Okay, this code architecture is following ADK framework. So we have to build an agent py file with the root agent, and in that object definition, you need to use the LLM agent to create that with a name, model. Here I use the Gemini 3 Pro preview model to implement the backend intelligence, and the instruction is defined here to ask the model how and when to use these tools when they asked for document search related questions. And also you should put all these tools into the list objects. Here I defined many tools with different purpose that aims to demonstrate the patterns that we have read in the blog post. And all these tools are defined in the tools py file as several functions. So first, the handle pattern. We have to look at the list documents function and also tool. This implements what the block calls relevance management for artifacts. So you will notice the function signature is the tool context as a argument type. This is the ADK context type we discussed earlier. The tool returns a dict, which ADK automatically serializes and includes in the model context. By return only metadata, we keep that context very, very small. Here a document is some quick structure that we fake some metadata and content. We create the document information and fake some content into a structure to simulate the document storage. But in production, we will use a database for sure, or some file storage service for the real case. Now let's look at the load document. This is where we see two key APIs from ADK working together, which is the tool context state and tool context save artifact. The state is a dictionary-like object that persists across tool calls within a session. When we write it, we use temp as prefix and current doc ID as a name, and we are storing a small string, just as the document ID, into the session state. It won't persist after the agent finishes responding. Then we call tool context save artifact. This stores the actual document context externally, not in the prompt, not in the state either. So the artifact is addressed by name like a file system. This is the separate storage from presentation principle in action. And let's scroll to analyze document function. This demonstrates how tools communicate through state and load artifacts only when needed. So what happened here, you see, the function doesn't take doc ID as a parameter. Instead, it reads from the tool context state get function to get it. Then it calls load context load artifact to retrieve the content. And the key insight here is this content was never in the prompt. It was stored externally by save artifact just now. And now we are loading it on demand, only when we actually need to process it. This is the pattern in the blog post called on-demand loading pattern. The artifact doesn't sit in the working context for every turn. It's loaded only when this specific tool needed. Now let's see save user preference function. So here we will use state prefixes. Finally, this shows how the prefix system organizes state by lifetime. We are using user here as a prefix. This tells ADK that this data should persist at the user level with a prop session service. Backend, like a database, this preference would survive across the sessions. Because the user preferences like I like brief summaries, something like that, should persist forever across the lifetime of the model conversations with users. So this is how ADK implemented the blocks tiered architecture at the API level, same state dictionary, different prefixes, different lifetime. Like here, we can get the user's preference through the other tool, get user preference, or through the conversation lifetime. Also, we have a clear current document to do the clearance from the state. To run this ADK, we can simply type the command ADK web under your project folder. And there will be a web server on port 8000 established. So you don't have to build any front end for your agents just make sure your agent is defined properly and in the proper folder structure, and then you will find your agent is working from the ADK web UI. Okay, so first let's simulate the handle pattern. I'll type, what documents do you have? So watch the trace viewer here, or just looking at the conversation record here. The agent calls list documents tool, which returns the metadata only for each document that we create in our tool definition here. And you will find there's no content provided. The response shows the title and ID, but the actual document content never touched the prompt. So it's asking me, please let me know which document do you want to load. So I will say, load the Q3 report. Here we prove the state of data flow. The agent calls load the document tool to check the stated panel. You remember that we put the temp as a prefix to the current document ID and title are now populated across the tools. But the real content is saved in an artifact and not sitting in the state. So it will not provide the content here. Just ask me if I want to see the specific content that you ask questions. Now I want to say analyze it. Here the tools call several analyze document, load document, and analyze document again to make sure it really specify which document to be read. Because the previous load document is only temporarily passing, so here it had to load the document again to know which document it should do the analysis. So that internally the tool loads the artifact, which is actually the content. Here, the content of the document. So this is the analysis report. Based on that, this is the key insight here. The tool's communication through state, not by passing huge payload around, right? It's actually read the artifacts instead of the state and instruction pass over each other. Now I will say something like, I prefer brief summaries to test the state prefix. So it says, I saved your preference for brief summary. So if you remember in the code, we use the user prefix to store the preference so that it will persistent across the sessions over the lifetime of the app. Let's verify it by asking, what are my preferences? So it's get the user preferences from the state to give you the answer brief. So basically these conversations looks very simple, but the secret is that the agent is using tools to do the response generation instead of looking at the history messages. That gives us an opportunity that if we extend this application to be more practical and to be much more complicated, it can still working very well and also can save much more time for execution and cost for tokens, and can eliminate error responses, more stable result by performing this very efficient and reliable context engineering guideline. That's all for today. If you have further questions or ideas, please drop them in the comments below. Thanks for watching. I will see you in the next video.